here with Mihael from sCrypt.
Yes.
Which is a company that does what?
Well, our main flagship product is a compiler that compiles high-level TypeScript code into Bitcoin script code. And especially now with, we were initially starting off on chain which has all of the opcodes enabled in Bitcoin scripts specifically, such as opcat and opmul. But we found out that all we need is basically one little opcode in BTC, opcat, and it enables us to do much more than Bitcoin currently does. So Bitcoin essentially goes from a digital gold simple transaction machine to a full computational machine. But these scripts, these covenants can get quite complex. They have many thousands of opcodes in them, and it's really cumbersome to write it all out in assembly. And that's where sCrypt comes in. You write out smart contracts or covenants, as they're called also, in a high-level language. You compile it down to script, Bitcoin script, construct a transaction, and broadcast it. That's basically what sCrypt does.
And you guys have been doing this on other Bitcoin, like Bitcoin forks of Bitcoin, for quite a while now, and you've been implementing this most recently on Fractal, which is kind of tip of everybody's tongues right now. And it's interesting because there's been this narrative, shout out to the Taproot Wizards, of like, let's bring some of these opcodes back, specifically opcat. And here comes Fractal. And you guys, Fractal's got cat enabled. You guys immediately launch a token standard, and it generates a ton of activity on chain. Let's just jump right to specifically, what is this CAT20 token and how does it actually work?
Okay, yeah. So CAT20 token is a layer 1 enforced token standard. What that means is you got this. Each Bitcoin transaction has a script in it, right? And it's a covenant script. And this script in CAT20 does the whole validation of the token itself. It doesn't need any external services like Ordinal does. Ordinal needs an indexer. For example, I can create a valid Bitcoin transaction that's an invalid Ordinals transaction, and the indexer will reject it, but still the core network will accept such a transaction. But with CAT20, everything is done by the miners. Everything is done by the layer 1 network. So for example, if I construct invalid CAT20 transactions, it will get rejected by the miners. So that's the major difference. It's much more powerful in that sense than Ordinals is.
Yeah, and because like Bitcoin itself does not, Bitcoin itself does not natively enforce this type of logic to enable tokens. Those tokens have to be, and we've seen this with like ancient token standards like Omni, to kind of like crowbar in tokens onto the Bitcoin network. But you guys have demonstrated that you can enforce token state on a layer 1 blockchain with CAT. Now, I've said that like tokens are not really what I enjoy talking about, but CAT is a really dynamic opcode, and you can do a lot of things like this. You brought up covenants and therefore vaults. Tell me in your own words, what are covenants and vaults?
Yeah, sure. Yeah, as you said, opcat is a really simple, elegant opcode that enables many things, such as covenants. So, what are covenants? Covenant is just a Bitcoin transaction that has a specific covenant script in the output or the witness script. And what it does, it enforces the structure of the next transaction. For example, I can make a payment to you, but I can restrict the next recipient, for example. That's what a covenant is. And you can do things such as recursive covenants that do this indefinitely, right? And with this mechanism, you can also, because you can introspect a transaction, you can also bring in the ancestors of a particularly executing transaction. And that way you can also validate the whole history of a token. And that means is... You can do an inductive proof, for example, that CAT20 actually utilizes of just including the genesis transaction ID and the output index in an operator, combined with the recursive covenant script. You don't have to track the whole history of the token to verify that it's from the valid genesis, that it's not some fake Sybil coin. without actually checking the history. You just verify the last transaction and that's it. You know the whole history of it. And that's things such as this become possible just by re-enabling like one simple opcode, which is opcat.
Yeah, and you would call that, say, indefinite just indefinite, like reproducing transaction.
Yeah.
You might call that a smart contract to interact with.
Yeah. It becomes essentially a smart contract. Yes, exactly. Yes, but it's a bit different than in the Ethereum world, because in the Ethereum world, smart contract is its own separate entity. But in an UTXO world, such as Bitcoin, the smart contract lives in an UTXO. So each update to the smart contract is a new transaction that unlocks the previous UTXO,
which is pretty cool. I feel that like we need probably better language to distinguish a smart contract on the blockchains from like this almost like little machine that is this UTXO state machine.
Yes,
in a way.
Yeah.
Do you have any thoughts about this? Like, I'm often kind of on the fence about like whether even to use the term smart contract.
Smart contract, the term itself is pretty stupid because it's neither really smart, it doesn't do any intelligence, and it's not really a contract in the law definition, right? Yeah. So the smart contract itself, but it's what people are stuck with. Yeah, but I agree that in a Bitcoin world, it's a bit, because you usually think about Ethereum when you hear smart contract. So covenant is I think it's a better word for it. Yeah, because covenant, you see, it's this thing that enforces the next state. Yeah, and it becomes sort of a smart contract. But yeah, covenant is a good starter word, in my opinion, to not get the two things confused. That you know what you're talking about.
Yeah, it's funny because I think about like how Casey introduced ideas of ordinals and inscriptions, but everybody calls inscriptions ordinals.
Yeah,
and I feel like you get to introduce one new word at a time.
Yeah.
And so maybe covenants is that word, and so people just reframe how they think about it. What are other interesting things you can do with covenants? This is a really broad design space.
Yes.
I'll throw it back to you. What's the most interesting thing to you that you can do?
Well, you can do many things. You can do AMMs, you can do DEXs, you can do atomic swaps. You can do, for example, cross-chain of Bitcoin-based chains. You can do cross-chain operations because you can verify a Merkle proof or an SPV proof from another chain on a different chain. And that opens up a whole lot of possibilities. You can do games. You can do tic-tac-toe with a covenant on-chain, which is a really simple example, but it works. And you can also do like message boards and stuff like that. Yeah, I mean, really, imagination is the limit. I don't know what's possible.
There's this line from Pete Rizzo, who's a well-known like Bitcoin historian, and he talks about we might be entering into an era where there are the Bitcoin monetary maximalists, and then there is this new movement of Bitcoin as a platform. You sound like a person who thinks of Bitcoin more, that you wish Bitcoin could be more like a platform.
Yes, I think Bitcoin has the potential to be, it was the first blockchain, it could be the last. It basically, we're in a phase of rediscovering that this thing can do pretty much everything that each other chain, which is supposed to fix Bitcoin's shortcomings, it can be done on Bitcoin, basically. Again, and that's in my opinion is a really great thing, because my personal opinion is like a multi-chain world. Yeah, it's fine, but it's gonna aggregate towards one chain because it just makes life simpler, right? You don't wanna, how do you do real life stuff with like 1,000 different blockchains? It will all converge into one, and I think Bitcoin has a shot of being that one.
Bitcoin Season 2 is brought to you by Botanix. Botanix Labs is pioneering a new direction for DeFi with the first EVM L2 running on Bitcoin that's built to be forward secure, decentralized, and share gas fees generated by the network with users. See the future of DeFi at Botanix, botanixlabs.xyz. One of the, I think it's not as, I don't think it's as like popular of a narrative, but something like CAT or Covenants could really improve the privacy of Bitcoin transactions. Are you familiar with some of these ideas or schemes to use covenants to improve like base layer privacy?
Yes, you could. You could use. You could build a mixer. I mean, I'm not sure about the legalities of such a thing, but
I like talking about these because the past year has been bad for Bitcoin privacy tech.
Yeah,
and I look and I'm like, if you're a privacy advocate, then like you've got to be a pro covenants on Bitcoin, and so
it enables a lot of these aspects, like privacy aspects as well. It can even, like Opcat lets you do ZK snarks or zero knowledge proofs for that matter on natively on Bitcoin itself, and that opens up. That's a different thing that opens up a whole new world itself, right? So zero knowledge technology, and that could be also used for many such use cases. Yes.
And I had tried to ask you this a bit earlier, but we got cut off. But I wanted to go back to this idea of vaults improving self-custody of Bitcoin. Like, this is a huge pain point for a lot of users. I think Udi talks about this all the time. It's like, just like the private key system, and like securing your private key and securing your mnemonic seed, like, it's very clunky. It just doesn't it doesn't work very well for most people.
Yeah, even for technical people.
Yeah, like I can't tell you, a lot of my like super techie friends screwed up self custody because it's just hard.
And now imagine your grandma doing something like this. Right?
Exactly, and everybody tries to solve this with like, we're going to improve the UI, or we're going to try to do some kind of like layer 2 thing. But like even those seem to be like not really working that well. But I've heard some very compelling arguments for vaults to improve custody, as like clawback mechanisms, or like failover for like different like keys to sign for transactions. Mm-hmm. Can you explain how one or any of those work?
Yeah, for example, a vault. There are many different types of vault implementations, but one that you could do, for example, with Opcat and no covenants is. You pretty much lock it into a vault covenant, and if you want to withdraw from it, you got a certain time period. You broadcast a transaction, but that Bitcoin will be in a limbo state, right? This covenant will be in a limbo state, and you will get notification that somebody tried to withdraw this, but you'll have a certain period of time to cancel this and return to the covenant to the initial step. Or if it's you, probably no one will cancel it, and once using unlock time, for example, you can enforce that after like a day or two, you can complete the withdrawal, for example. Yeah, that's like a good vault implementation that's made possible by Opcat.
Yeah, I keep going back to this. I kind of almost want to say this back to you because this would radically change the self-custody game. Like if you have what's like basically a hot wallet with a lot of Bitcoin in it, you and someone is able to steal that because it's just very active on the internet, and someone's able to send it. You could set it up so that they can send it, but for 30 days, you are able to claw that back. Yeah. Which changes the game, and I think it changes the wallet design landscape pretty significantly.
Yeah, it does. Yeah, and it's a whole computational machine. You can implement many different examples. You can create better multisig vaults, because for now, if you lock some funds in a multisig, you need to construct this transaction off chain, and I need to sign it, hand it over to you, and then you sign it and hand it over to someone else.
You pass around wall descriptors, and you've got to You got to pass around wallet descriptors, and you've got to hand partially signed transactions to each other. Yeah, exactly. But with a covenant, everything is on chain.
And for example, we might have a multisig group, and one guy goes rogue, and he starts signing. But each of us will get a notification like on chain, like what is this guy doing, and we can quickly coordinate like. Yeah, he's trying to go rogue. Don't trust anything he says. We're not going to sign, and it makes the whole process a whole easier to manage, because you don't have this off-chain stuff going on. Everything is going on in public, could be going on. But again, you could also use privacy features as well, which are enforced by covenants. Yes.
When I started out in Bitcoin, I had this idea and this view that it was this super-powered programmable money. This was a major narrative like 10 years ago. And right now, frankly, it does not feel like magic programmable money. But what you're describing to me sounds a little bit like that original narrative. What are your thoughts on this?
Yeah, because right now with the current state without Opcat, it's really, there's only so many things you can do. There are a few different use cases, but it boils down to a couple of them. It's not really like magic programmable. It's like money with 5 features.
Yeah.
But with Opcat, it becomes like you go from 5 features to basically infinite with just one simple opcode.
So let's imagine that we get Opcat on Bitcoin L1. Do you think that opens up, things up to have future soft forks for additional opcodes?
Well, I mean, once you have Opcat, you don't really necessarily need a lot more. I mean, you could enable parts of like opcodes that were enabled in the past, such as opmul, which multiplies 2 numbers on stack together, and that wouldn't really hurt. But once you got opmul and Opcat, it becomes fully programmable. You don't need more, right? Because you make a huge leap basically with just one. You don't really need like another like op verify zero knowledge proof or whatever. Like each new thing comes around 2 years, we got another soft fork for some features. It's like, no, you just make the script itself, scripting language itself as powerful as it can be to avoid future soft forks. So like Opcat, I would say, is like anti-soft fork technology.
That is an interesting perspective. I'm not keep going. I keep talking through.
This. That's pretty much it. Once you have this level of power, I mean, it's just like imagine you have a computer at home, but it does only things that its creators came up with. Yeah, it can do a calculator. Okay, next year we're gonna do like a text processor. Yeah, next year maybe we're gonna do like a web browser. No, you make a CPU. It has a set of instructions that make it powerful enough that you can build on it anything you would like, and we don't have to think about it as CPU makers, right? And I think that same idea should apply to Bitcoin itself.
This is really interesting. Tell me about what you are currently working on. I know you guys have you put out Cat 20, but like. What are you currently working on? What's in development right now?
Yeah, we have lots of different projects. So one big one that I can name is we're also helping a company called Starkware build a Bitcoin bridge for their layer.
You guys got a grant from them, right?
We signed a contract to build out a proof of concept bridge using governance. Yeah, it's the same stuff that we talk about, but they will use it to make a bridge for Bitcoin that will that their layer 2 network Starknet that they call it will use and verify itself on. Yeah.
On the topic of bridges, how does this particular bridge work? Are you allowed to talk much about it? Or
I think it's the code is
maybe
public.
Maybe you could some highlight.
Yeah, we're currently in a proof of concept phase, and it basically the way it works is users basically create transactions that are either withdrawal requests or deposit requests on chain. These are all transactions on the chain. And then an operator aggregates those, but all of the logic is enforced by covenants. So he only proceeds the covenants without necessarily, he cannot cheat. It ensures that the operator cannot cheat. And they aggregate all into like a Merkle tree, and then you add them to a main covenant that keeps track of the overall state. And you can do the vice versa. For example, if you have 10 withdrawal requests, you can then expand the stuff that was withdrawn from the main contract into individual transactions that pay the user back for their withdrawals.
This is the unilateral withdrawal, the fabled unilateral withdrawal that I hear about a lot.
Yeah, pretty much, yes.
What do you think what are your candid thoughts of the current state of Bitcoin bridges without Opcat?
Yeah, they usually rely on some, like basically threshold signatures or something along those lines. You got a fixed set of, for example, Liquid works like that.
It's like a federated multi-sig.
Federation, and that's pretty much it, really, for most networks. You got some interesting things such as merge mining and stuff like that, but yeah, using covenants you can do a lot more than these things, and it's more secure as well.
On the topic of this Bitcoin script and engineers who are familiar and competent with Bitcoin script, on the topic of like just Bitcoin script in general, I guess I used to think that there were a lot of engineers out there, Bitcoin and just the broader Bitcoin forks of Bitcoin ecosystem, and that there were tons of people who are pretty proficient with this, but but there's not.
No.
I feel like you probably know everybody already.
Yeah, I mean, he was just showing me some conversation that they had on Telegram, and I was like, yeah, I know this guy. Yeah, I know him too. Yeah, and we're like, like a handful of people that really are proficient in this, and yeah, that's surprised us as well. It's like you got this thing that's so powerful, but the knowledge really isn't there. So yeah. Our aim, like with this, the presentation that I had and stuff like this, is bring awareness to it. Maybe get competent developers interested in this and start picking it up, because it has a lot of potential. Yeah, and it would be a shame that no one really explores this potential.
What do you think the main barrier to future developer onboarding is? Why do you think there's not more developers currently who are proficient? Because there's a lot of smart people in the world, just why are they not working on Bitcoin?
I mean, I think part of it is the narrative of Bitcoin being this stupid digital gold that doesn't do anything else. And people just don't know about, they never heard Bitcoin can do smart contracts. What? Like, I thought it can only do like simple transactions. And yeah, that's the narrative is part of it. So the goal is to change this narrative itself. Yeah.
I guess I'll try to wrap it up with a final question. What is most exciting to you right now?
Well, Opcat, yeah, covenants. Well, the possibilities that it opens up, so many possibilities of Bitcoin, and that we finally got something that can do all without being some new chain and new thing, all of itself, and the beauty of it, and the sort of not irony, the beauty of it is the original blockchain. It all goes back to Bitcoin.
We spent many years wandering the desert. Everybody goes off to other chains. They go to Ethereum. They go to Solana. Those are fun. Yeah. You can make a lot of money, but Bitcoin's here and never left. It survived, and it originally had.
The funny thing is, Ethereum probably wouldn't exist if it weren't for the bug in the implementation that got it disabled in the first place.
That is a spicy opinion. I like that. Yeah. You have final thoughts?
Yeah, I follow us on Twitter and learn. Just try it out and see what you can build, and because that's the only way to go. Because we're a team of 7 guys right now, so we can't do it all. So
there's way more than things for just 7 people to build.
Yeah, there's way more. There's like pretty much, it's infinite. It really becomes infinite. It becomes the whole computational machine. Yes, and the possibilities are really endless. So it would be a shame to go such an opportunity to go to waste.
Well, thank you so much for sitting down with me again. This is kind of an off-the-cuff conversation that we had here in Amsterdam. Didn't plan this. I really appreciate you. I'm glad that you helped us get this lined up. So I will see you on the internet.
Yeah, thanks for having me.